Hi everybody, I'm going to try and get some answers up for these other supplemental problems that are at the end of your review packet. This first one is actually much more difficult than you would have to do on the final exam, so I'm not going to spend a bunch of time going through the answer. You would make a graph, find the relationship, linearize, and so on and so forth, but the numbers are not friendly enough for you to have done it by hand. This would be more of like a logger pro kind of thing to get the exact slope. So we're just going to skip number 1. We're going to jump to number 2. A couple classmates didn't catch this train. Instead, they decided to borrow their dad's car and try to catch up to the train. They depart at 9:01, and as you read in number 1, the train left at 8:53. So they're leaving 8 minutes later. The train accelerates from rest at 0.1 meters per second squared. The car accelerates at 1 meter per second squared. At what time does the car catch up to the train? So, car, train, final position equals VIT plus 1/2 AT squared plus whatever initial position you had. Same thing for the train. They start from the same location, so that's nice. Final position of the car, we don't know. Initial velocity starts from rest, so 1/2, 1. The car's going to start 8 minutes later, so 8 times 60 is 480 seconds later. So t minus 480 squared plus 0. Train starts from rest, 1/2, 0.1 t squared. Okay, so the right-hand side of our equation is going to be 0.5 t squared. Left-hand side is going to be 0.5 times, we need to FOIL this, so it'll be t squared minus 960t plus 2,30400. That's 480 squared. So now I still have to distribute 0.5. So 0.5 t squared minus 480t plus 115,200 equals 0.5 t squared. I apologize, I just realized I was missing a 0, because 1/2 of 0.1 is 0.05. So we'll just fix that. No sense in restarting the video. So now we're going to get everything on the same side of the equal sign so we can do the quadratic equation. So I'll bring the 0.05 to the other side. So 0.5 minus 0.05 is 0.45 t squared minus 480 t plus 115,200 equals 0. Do the quadratic formula, and you get time equal to, this equals 702 seconds. Now if you're asking what time does the car catch up, you could say 702 seconds, or you could change that into minutes, which is 11 minutes, 42 seconds after the train started. So we had 11 minutes, 42 seconds on to 8:53. Or sorry, 8:53. So you had 11 minutes to that. That's 9:04 and 42 seconds. Obviously, you wouldn't have to give me the time if you just gave me 702 seconds. That would be fine, not the clock time. Next one, you make it to school. You decide to have some fun and play a game with friends. You take aim at the goal and throw the ball as shown. If the defender doesn't move, do you score? So you first of all have to get your shot over the hand of the outstretched defender, but then also have it fall enough to make it into the hoop. So you kind of have to do this in 2 parts. Make sure it goes over the hand of the defender and low enough after the defender that it goes through the hoop in the goal. So I'm going to break my throw into x's and y's. 15 sine, 15 cosine, using the angle, 0.5 and 9.64. Now I know the range to the defender is 18, so I can do 18 equals 9.64t to get the time to the defender. 18 divided by 9.64 is 1.87 seconds. Now I can find the height of the ball at the defender's range to see if it goes over the hand. So I'm going to do delta y equals my initial y velocity times time plus 1/2 negative 9.8 times the time squared. That gives us a delta y of 4.42 meters. And where your hand currently is 15 meters above the ground, and the defender's hand is currently 19 meters above the ground. So if you add 15 meters to the delta y, you get 19.42 meters, which means the ball clears the defender's hand. Second part of the problem then is to figure out, okay, so it clears their hand, but how high is it when the range is 25 meters? So I kind of start over and I say, all right, my range is going to be 25 meters away. My x velocity is still 9.64. Find the total time to get to the goal. 25 divided by 9.64 is 2.6 seconds to get to the goal. Again, find delta y at that time. So VIY is still 11.5 times 2.6 plus 1/2 negative 9.8 2.6 squared gives you a delta y for the entire throw to the goal of negative 3.06 meters. So let's try and make some sense out of this. The ball starts 15 meters above the ground, and by the time it gets to the goal range, it has dropped just over 3 meters. So if you do 15 minus 3.06, you get 11.94 meters off the ground, which is right at the top of the goal. So yes, he makes it. Last question here, you've got Dobby hanging up a chandelier that he was going to drop on Bellatrix Lestrange, and we want to know what angle he needs to hang the cable so it hangs in equilibrium. So your free body diagram, you got your 60 kilogram chandelier, so 60 times 9.8 is 588 newtons pulling down. You've got one cable up and to the left whose tension is 300 newtons. It gives you that top angle, which is the same as the angle in this triangle, 65 degrees. And you're going to hang another cable to try and keep this in equilibrium, which means your x components have to be the same, and your y components add up to 588. So using my 300 and sine and cosine, I can find the x and y components of the left rope. So 300 sine 65 gives me the y component of 270. We'll just round it to 272. 300 cosine 65, 120, we'll just round to 127. So that has to be the 127 on the other side. We can take our 588 and subtract the 272, so we can find the y component of this other rope. So that's 316 newtons. And then solve for theta using inverse tangent, because tangent of that angle is going to be 316 over 127. So inverse tangent of that is 68.1 degrees. Hopefully these reviews helped. Good luck studying. I hope to be back to school as soon as I can, but I'm not sure how long that's going to take. Good luck.